Assalamu alaikum warahmatullahi wabarakatuh. I'm Ziad from Tabe University, and I'm gonna explain the fourth chapter on static, which is trusses. Trusses, a framework composed of member joined at their ends to form a rigid structures, is called trusses. Bridge, roof support, jerks, and other such structures are common examples of trusses. There are two methods of solving a truss problem: method of joint, method of section. First of all, method of joint. The method of joint is a way to find a known force in a truss structure. The principle behind this method is that all forces acting on a joint must add to zero. If there were a net force, the joint would move. Example on method of joint. Compute the force in each member of the located centrifugal truss by the method of joint. So the question need to calculate all the force member on this trusses. So the trusses is just like the previous chapters, but the huge difference is in the previous chapter we want to find the external forces. But here in this chapter, in the trusses chapter, we should find the internal forces, which is this and so on. So I'm gonna solve joint by joint to find each member. So I'm gonna start with the joint. First of all, we should draw a very bad diagram. Then we should find the supports. So I'm gonna take the moment around E to find the tension. So, and the tension is equal 80 kilonewton. Then I'm gonna take the Fx to find the Ex. So 80 cosine 30, which is this one, minus Ex is equal 0. Then now I'm gonna find the Ex, which is 69.3 kilonewton. Then I'm gonna take the Fy to find the Ey. I'm gonna take the 80 sine 30 minus 20 minus 30 minus Ey equals 0, and Ey is equal 10 kilonewton. And then I'm gonna take joint by joint to find the member. I'm gonna take, first of all, I'm gonna take the joint A. So you should draw a Hilbert diagram around the joint A. So I'm gonna take the Fy to find AB. So AB is equal 34.6 kilonewton, and it's in tension because I assumed it's in tension, and the answer isn't minus. So what I assumed is correct. Then I'm gonna take the Fx to find the AC. So AC minus 0.5 multiplied by 34.6 is equal 0. So AC is equal 17.32 kilonewton, and it's in compression because I assumed that it's in compression here, so it isn't, it's not a minus, so it's what I assumed is correct. And then I'm gonna take the joint B to find the BD and the BC. So I'm gonna take the Fy to find the BC, and BC is equal to 34.6 kilonewton, and it's in compression. Then I'm gonna take the Fx to find the BD, and BD is equal 34.6 kilonewton, and it's in tension. So then I'm gonna take the joint C, and I'm gonna take the Fy to find the CD here, and I assumed it's in tension here. So if it's minus, it's in compression. If it's not minus, it's in tension. So CD is equal 57.7, and it's in tension. So what I assumed is correct. And then I'm gonna take the Fx to find the CE, and CE is equal 63.5 kilonewton, and it's in compression. Then I'm gonna take the joint E to find the DE. So I'm gonna take the Fy to find the DE, and DE is equal 11.55 kilonewton, and it's compression because I assumed it's in compression here. So that's it. The second method is method of section. In this method we will cut the truss into two sections by passing a cutting plane through the member whose internal force we wish to determine. This method permits us to solve directly any member by analyzing the left or the left or the right section of the cutting plane. So there are steps of solving a section method, which is, first of all, always start by collecting reaction at support. Second, make a slice through the member you wish to solve. Third, do not cut more than 3 members, because into the problem we have just three equations, so you can't cut them more than 3 members. Fourth, treat the half structure as its own static truss. Fifth, solve the truss by taking the sum of forces equal 0. Sixth, take the moment about a node of more than one unknown member. And I'm gonna take an example of on a method of section. So the example says calculate the force in member dj of the whole row of truss and illustrate it. Neglect any horizontal components of force at the support by knowing that ay is equal 18.33. So I want this section, which is dj, so I can cut it from here to here, but if I cut it from here to here, this force will be unknown, so I'm gonna cut it twice. So the first section will be this section, which is I'm gonna cut it from here to here to find Cj to find this member. Then I'm gonna take the moment around A here. I'm gonna take the moment around here, A. So Cj is equal 14.14 kilonewton, and it's in compression because I assumed it's in compression here. Then I'm gonna take the moment around J. I'm gonna take the moment around J to find the CD here, and CD is equal minus 18.63 kilonewton, and it's in compression because I assumed here it's in tension, and the answer is minus, so it's in compression. Then I'm gonna take the second section to find TJ. I'm gonna take the moment around G here to find DJ, and DJ is equal 16.67 kilonewton, and it's in tension. And that's all.